Yo. So, how many class were today?
Sir, only one, sir.
Which class?
Two, sir, two. Where
Sir,
one?
two seminar and maths classes, sir.
Okay. Do you have any problem to understand the subject which teachers are teaching you due to
Sir,
online?
maths से एक तो problem है sir. Maths का एक तो follow करा problem है.
Yes, sir.
So, lab. So, what are the lab actually going to right now?
Maths, sir, maths,
Sir,
mathematics.
maths.
Maths. Why? What is the problem?
স্যার মানে স্যার হচ্ছে মানে ম্যাম যে আছে মানে মানে জয়দীপ স্ক্রিন শেয়ার করে আর ম্যাম ওই স্ক্রিনের থেকে বলে তো স্যার মানে দুটাকে সাইমালটেনিয়াসলি দেখতে আর তারপরে বুঝতে স্যার একটু মানে ওইদিকে একটু প্রবলেম হয়ে যায়
Hmm. Okay. Sometimes it's happened. There will be difference. There such a difference that between two teachers among teachers. Some deliver well, some deliver not so good. Anyhow, it's happened. But I know that you once you have the materials, once you have the class notes or books, then you probably able to prepare for it. Okay, these are not big issues. In my time, it was also there. Some teachers used to deliver such way that I could not make it understand, or I could not understand myself also. So it's a very common problem. Anyhow, so yesterday I started, or last day I started about static characteristic of instruments, right? And I discussed about some kind of stability, reproducibility, repeatability, precision, accuracy. Now today I am going to say some of the I want to finish the static characteristics first here, and definitely after that I will discuss about some error, gross error or something like that, and then I will discuss about the noise. We should have some should have some knowledge on noise. Let my Microsoft whiteboard be here, then I will discuss this one, because this one I am going to ask a few questions from what I said earlier. So what do you mean by sensor? What do you mean by sensor? Can I answer it?
Something like senses, like physical quantity, like physical things like temperature, pressure. Uh, yeah, this is gravitational pull. Like
Anything more?
we have
Now, what is conditioning circuit? What do you mean by processor? I mean signal processor or data processor. Hmm? What do you mean by processor?
sir after the initial input is sir we receive the initial input from the transducer we have to convert it because for that we need the processing unit we need to convert it from analog to digital in many cases and for that we need the conditioning and processing unit
Yeah, very good. Okay. So, can you say about precision? What is precision? Sika. Sika.
Sir,
Serial de churi.
sir, Precision is basically degree of refinement with which a measured value is stated.
Precision is precision is
Degree of refinement with which a measured value is stated.
degree of refinement means what do you mean by that
Sir,
degree of
accuracy
refinement?
in degree of closeness to true value.
No. What do you mean by degree of refinement? What do you mean by degree
The
refinement?
closeness of the measurements, like the closeness of the measurements, the repeating measurements that you have taken.
Repeatedly measures, then we'll find the numbers of data as the output of the device, and we have to check how much close they are. If they are closed, they are in a cluster, then we'll say that degree of refinement is much more higher than of the normal one. Normal one means which are not close to each other, which are not close each other. Okay. Anyhow, let's come to the another point, that is about the zero stability. I said about zero stability last day. Now come to the point of resolutions. So let me know about the stability. What do you mean by stability?
Sir, the ability of a measuring system to maintain its standard of performance over prolonged period of time and with variation or disbalance from side.
Ability of measurement system to maintain its
Its
standard
standard of performance.
over prolonged period of time. Anyhow, very good, very good. So I got your response, and it's very good. Now come to the next point, resolutions. Resolutions, you are quite familiar with these terms because you are quite mature about to buy a new laptop or new mobile phone with a higher resolution. Even about the camera, you know very well about the camera means by a particular characteristics regulations. So what do you mean by regulations? Can you say it in your terms? So you normally say, what is your camera resolutions? You commonly say, this kind of terms when you are going to compare with some your mobile with other mobiles. So what do you mean by resolution? By your words, I want to know.
So resolution means clarity in image or picture.
Parvez,
Or
okay.
the
Anything more?
number of or
Sir,
the
Saurabh,
number of pixels.
Mansoor,
So resolution, the number of pixels in a digital image.
okay.
Sir, the
Uh,
actual image is
Mansoor,
analog. Oh, okay.
Yes, sir.
can you
Hello,
say
sir.
what about the connectivity in your area? Net connectivity, is it good?
Sir, it is good.
Very good. Then can you tell me what is resolutions? By your
Sir,
words,
what is
not necessarily you have to.
sir? What is resonance or what is resolution?
Resolution. I ask for resolution
No, sir.
because you have used that word commonly when you are going to buy a mobile phone or when you are going to compare mobile phone with others.
Yes,
So
sir.
it's very common. I mean, use something you understand by this word. What do you understand by this word? Like Sudha Sattu said, Saurabh said, Parvez said. He says something
Sir, the
about your
quality of the
understanding about
picture.
resolution.
Sir, resolution is mostly used in
Okay, Aniket.
camera for image quality and the stuff. It always it's related to quality.
So look, let me inform you about the images. Image normally there is a two kind of image. One is in digital display. One is a pixel based image. And one is dot matrix or dot based images. Okay, but when we are talking about the resolution general a property of instrument, and what it means that resolution actually the smallest increment in input signal. What What I said, smallest increment in input signal due to what output response? Due to what? Smallest increment or smallest change in input signal to which or due to what the measurement system response. Get my point? This is the general statement of the resolutions. If you think about your images, what are the smallest change? When suppose you are going to say is pixel wise pixel change, then you want to expect that when you enlarge your images, every pixel can be viewed, or every pixel change in every pixel can be observed. Then we can say that image is good. And how it is possible? When my camera have a capability to get the information by from the real site or real scene to your camera with a maximum information. I mean, with a maximum information in sense of data, in sense of pixel, in sense of dot, in sense of anything. Okay, so when my camera can able to do this one, then we can say its pixel is good, its resolution is good. It's one example of the static characteristic for particular instrument, means camera. Not necessary resolution is a basic property or only one property of the camera. Resolution is a common property for all instruments. Suppose you have some kind of thermometer where you can say measure the temperature is 98.4 degree Fahrenheit. So how much decimal you can measure? 0.1 decimal. 0.1 degree centigrade or per degree Fahrenheit. But if your thermometer is highly regulated thermometer, then you probably able to detect that 0.00001. That's when the resolutions of the scale resolution is so details. Then the smallest change in temperature you can detect. Okay, so that will be the resolution of your thermometer then. So resolution is a common property of the instruments, and it is a static property of the instrument. First, secondly, general definition of resolution is the smallest change or increment in input signal to which the measurement system responds. Okay, is it clear?
Yes, sir.
How is it different from least count? Hello, sir.
Hello,
How is it different from least?
am I audible?
Yes, sir, you're audible.
Gulshan, I'm not listening. I'm not. You're not audible properly. Just say it properly.
How is it different from the least count of an
Yeah.
instrument?
How it is different from least count?
Yes, least count of an instrument.
Least count. Actually, this is not a property of least count of instrument. It might be a counting. It might be counting, but when we are talking about the property, there is defined. There's some kind of words are defined to explain the system specification. Okay, least count might be expression that how much it will count and how much minimum value it can able to count. But when we are talking about the resolution, it's a general property of the instruments, and it's defined by this word that there will be smallest change or smallest increment of the instrument. Sometimes the instrument can respond to the output due to smallest change, but your instrument scale or your instrument system is designed such way that the least count is much more higher than the resolutions. They actually keep some space, or they have considered the least count should be sufficiently high that the user can detect, user can easily complete his task, or user can execute his task or her task. But that does not mean that the resolution of the system should be same with the least count. Get my point? Like that, when we are going to measure body temperature 98.4, 97.6 or 100.2, 0.2, 0.1 is enough for us. If we are talking about the resolution, then we can say that a thermometer can be designed such way that 0.1234, 98.123, 97.215, that can be done. But this is not required. This is not required to express the body temperature. 98.4 or 97.3 or 100.1 is enough to explain the enough to execute the measurement Okay, so that's why the least count here is might be mentioned is the minimum. It's a 92 degree, and then after it can count 0.1 degree, 0.1 degree Fahrenheit intervals. But that does not mean that the resolution of the instrument should be that. Okay, it's depend on the manufacturer how they provide the data, how they provide specify the instrument. But basically, we used to say the property of the instrument is the resolutions. Sometimes the resolution and list count is same. Sometimes resolution and list count is same. Sometimes manufacturer actually mention regular list count by the term list count instead of resolutions. But resolution something related with the basic property, and list count may vary depending upon the manufacturer to manufacturer and depending on the applications. Okay, whenever you are going to develop instrument, basic name is a resolutions. Some name is very synonym to the resolution is called threshold value. Very confusing with the threshold value. Threshold means what? The minimum input for what output start responding. Output start responding. That does not mean that threshold is similar with the resolutions. I will come to that point later. There is another. Let me discuss this one right now. Threshold. The terms probably quite familiar with you, and it's basically it is found in mechanical devices. Mechanical devices, where the definition is quite similar like resolutions, but there is small difference. You have to listen it carefully. What about the threshold? Threshold is the smallest change in input signal for what output starts responding. Smallest change in input signal for what the output starts responding. And what is the resolution? Smallest change in input signal or smallest increment in the input signal for what output responds. That means that there will be certain changes like that. If I will change here 1 centimeter interval, for what the output will change 10 meter. But if I will change 0.1 centimeter, output will not change. Next, if I will change 1 to 2 centimeter, then output again produce sufficient high output signal. Okay, that's mean for 1 centimeter interval, what happens? The output responds, and it's enough to recognize. But when I am talking about the threshold, I can say 0 to 5 will be the value for what output will have no response. But when I will increase the input signal more than 5, then output start responding, and so on. So on means output from where output start responding means if you put a 6, 7, 8, you will find that there will be certain change in output signal, which might not depend on the input or might be depend on the input, but it will start responding from what? It will start responding from 5. Okay, so the definition having certain difference between resolution and threshold. And as I said about the list count is quite similar with the resolutions, but not every times. List count is basically given by manufacturer terms. So normal or generally the static test is defined by the resolutions. And resolution is perfect word to explain the sensitivity. You may say certain kind of sensitivity, not the sensitivity actually it is. I'll describe the sensitivity here also. The term is very confusing. One is the resolution, second is threshold, and third is sensitivity, and definitely about the list count. But list count, as I said, is a manufacturer given. Sometimes list count can be calculated mathematically. But if you talk about the resolution is a hardware property, and it is the smallest increment for input signal produce changes in output signal. But when we are going to talk about the threshold signal, for what we could say after a smallest or change in the input signal due to what the output start responding. Like in diode characteristic, you have seen that diode have a threshold voltage. 0.7 voltage is the threshold voltage for forward bias silicon made diode, right? So after 0.7 volt, the diode start responding. So threshold is there 0.7, but it is not resolution. If you talk about the sensitivity, what is sensitivity? Sensitivity defined as the ratio of the change in output signal to the change in the input signal. Mind it. What is the sensitivity? What is the sensitivity? I told you. Ratio of the change in output signal. Ratio of the change in output signal to the change in the input quantity or input signal. So it's a ratio delta I mean input signal, delta output by delta I. Am I right? Did you get my point?
Yes, sir.
So could you repeat once sensitivity?
What is sensitivity? What I said, the change in output due to change in input. So if you express this one by delta, let me open my Microsoft. Can I get a 5 minutes break?
Yeah, sir.
Let my Microsoft whiteboard open. It will take some time, huh? I'll come to you. Can you see that Jamboard? My word is having certain kind of problem. I don't know. It might be login problem. Ah. So I'm switching over the Jamboard that was probably given here. Is it very visible?
So people who have logged in through the laptop can view it, but people who have logged in through the mobile have to download an app for that.
So this is another problem, right? So image what is better, right? But I don't know. I need some time to fix this one. It's every time it's happened. I don't know. This time it is persisting. Is it visible now?
Sir, you are not sharing your screen.
I don't know what happened. It's very difficult to take a class in Microsoft Whiteboard, and even it is difficult to do the class with Jamboard when you have no apps on your mobile. Anyhow, what I was discussing, let it be prepared. What I was discussing about the sensitivity, it is a difference. It is a ratio between delta output, I mean change in output with respect to the change in input. Okay. So this is sensitivity. Another terms is very important for for any kind of instrument is linearity. You know that if the signal is linear, then probably the system will be considered. I mean, if the output is linearly changing with the input signals, then we can say the output is the best one. We have studied the log. We have studied the log to avoid the non-linearity, right? If y equal to e to the power x, then should I make it linear? Definitely no. The characteristic will be logarithmic curve. But if we take a log both sides, then log x will be log y will be x. So x and y will varying with respect to the log value of y. X is varying with respect to the value of y. Similarly, when we are talking about the instrument, we expect that instrument output should vary with the input signal linearly. I mean, it's expected to be a straight line. Would expected that there will be a sensitivity. There should be a sensitivity which will be 1 always. I mean, delta y by delta x should be a constant. Should be a constant. Delta y by delta x should be a constant. If the delta y by delta x is not constant, is not constant, then probably then probably it is difficult to use that instrument for particular measurements, but because of the non-linearity. So what we expect that system should have a linearity. Then definition of linearity is the proportionality between input quantity and output signal. I mean, what do you understand about the linearity? Linearity means the proportionality between input and output. Linearity of proportionality between input and output. That's mean if we think that dy by dx, then definitely dy by dx should be
Constant.
Okay. My whiteboard is fixed now. Expected. Is it visible? So first, what I said about the resolution. What is resolution? What is resolution? We said.
So the smallest increment in input signal due to which the measurement system responds.
Okay. Smallest increment
in input signal
of the input signal to which measurement system responds. What I said about the threshold?
The minimum value for which system starts responding.
Is a minimum value. You may say minimum value of input or smallest change or the change of input due to what or change of input for what output start responding. And third, sensitivity. Definitely this is static sensitivity. Yeah? This is static sensitivity. Sensitivity is the ratio of change in output to change in input. That can be say delta output by delta input. This is defined by S. Okay, if you take a graph over here, if you talk about the input, this is output. If signal is responding, what about the resolutions? Resolutions means when we are drawing the graph this way, this is responding graph. And if we take a graticle over here, let me so what I have taken a square unit area. Okay, that probably you graphically did this one. This is a list count you did. This is list count you did. Okay, so that's mean this is one for what? This is the smallest change of input for what? You can say this is the change in output. So that is definitely a resolution. You can reduce this one if your graph is much more like a millimeter graph. If it is, then the resolution is better. If it is micrometer graph, then probably for a small 1 micrometer change, you will find a certain change in output. So that's when resolution can be increased. If you talk about the threshold, then definitely due to the minimum change in input signal might be that like that the output might be like that output is here. So look, the input is here. For what there is a no output. So definitely this is called threshold. For minimum input, after what the output start responding. And if you talk about the sensitivity, then definitely this graph will be like that. Output, input, okay, and I am taking here the graph is like that. If it is like that, then if you think about the sensitivity, definitely you have to find out the linear region here. It might be this line will be linear. This line would be linear. Okay, in this area you have to calculate the sensitivity. It can be drawn this way. And this is what? Delta in. And what is this? Delta output. What is this? Delta input. Now what is sensitivity? AS will be here. Delta output by delta input. What about the threshold? This will be the threshold value. Threshold is might be X, delta X or something, delta XX bar or FC or C, whatever you can say. It's a threshold. If you talk about the resolution, definitely the resolution will be the smallest increment here. Okay. Another thing what I said is the linearity. Linearity is a proportionality. Look. If you think of linearity, this is output, this is input. If you think of response of an instrument, definitely whenever I am drawing that picture, you keep in your mind the input is x-axis varying, output is y-axis varying. What is that? This is characteristic curve, input output characteristic. What is that? Input output characteristic curve. What I said? Do you get me?
Yes, sir.
Input output characteristic. It is very basic input output characteristic to define the particular property of an instrument. Input is varying, output is varying. Is there a relation? Definitely there will be relation. Why that relation is here? Because the device is actually designed depending on the input signal and some mathematical or physics based some model through what the input is processed and produce output. So definitely there will be relations. It might be logarithmic, it might be sinusoidal, it might be cosinusoidal, it might be proportional, it might be any kind of exponential in nature. So there is a different kind of signal. Even it can be step input signals, output signals. So many signals are also there. So what I have to mean that due to variation of input signals, there will be certain variation of output signal. Now I am going to draw this one, and this is called characteristic of input-output characteristic curve. There will be definitely other characteristic curve, but it is called input-output characteristic curves in static domain. It's not a dynamic domain. So in that case, if I consider the system should produce that kind of graph. Now, if you consider output is y, input is x, and this is 45 degree. Sorry, 45 degree. So, what does it mean? The characteristic curve should be or will be y equal to x. Am I right?
Yes, sir.
Otherwise, you can say that it is a straight line equation equal to y equal to mx plus c, and m is tan theta. If this is 45 degree, m equal to 1, and c is the threshold value, c is 0 here, or intercept, c is called intercept. Am I right?
Yes, sir.
Yes, sir.
Okay. So that's mean here the y equal to x. It's a proportional signal. It's a proportional signal. Am I right?
Yes, sir.
45 degrees. We expect the output should be like that. Input is might be here. So that means the tan theta. If you talk about the static sensitivity, definitely it is going to be 1. dy by dx, it's going to be 1. So we expect that the sensitivity is good. So change in input, definitely one change in input produce one change in output. But we found that some instrument might have some kind of response like that. Some instruments may have some response like that. Some instrument might be like that. So what do we used to do? In that case, we used to make the car fitting technique. Car fitting technique means we consider that average line should be here. If we consider few points here, few points there, similarly we will consider the opposite direction, there will be some point, and we draw a average curve. Average curve means what? We consider the deviation of every point. Deviation of the every point, we add them and find the straight line. If you consider this one, then deviation is this one. Deviation is this one from the average line. Deviation is this one. Deviation, that's when the swing in both sides. We consider same swing in both sides, then we can able to draw the straight line. If the graph is like that, we'll consider the deviation this side as well as deviation this side will be added. These are might be error 1. If it is E1, then it is E2, then it is E3, then it is E4, and similarly here you will find 4 error: E1 dash, E2 dash, E3 dash, E4 dash, and then after what we do, we used to do E sum EI plus summation EI dash. Okay, these are the error. We expect that sum of error should be 0. We expect that sum of error should be 0. If sum of error should be 0, then we will say this is the perfect average graph. Am I right?
Yes, sir.
Any confusion here? Any
We know
confusion?
what the average graph is.
What actually means by average curve? Means there might be some data in both sides. It means that bottom side as well as top side. But when we can able to draw average curve, if we think that the error, I mean deviation from the from a particular point, what we have to do, we have to consider the middle some points at the middle of two data, and we have to check out the deviation. If the deviation of the both sides, sum of the deviation of both sides should be added, and if it is found 0, then we'll say it's a perfect average curve. You cannot do, if that kind of graph here, you cannot do a average line like that. Can you do?
No, sir.
Is it looking average curve?
No, sir.
Definitely not. So what is expecting, it should be like that. It should be like that, or it is still not. What you want to do, you again draw a straight line like that. So that's been several lines you have drawn, and what you are trying to find, you are trying to find the total error. You are trying to find total error. That error will be come by summing of the deviation every time at lower side as well as upper side. When you will find that total error is 0, that is that means that the average your average curve is perfect one, because you have considered the swing in both sides similarly or symmetrically. That's why the error is 0. But it is not possible every time. But you will find that E should be minimum value. It should be minimum value. Then it will be the best graph, best fitted graph, or best fitted curve. Okay, this
Sir.
technique is called best fitted
Sir.
curve.
So will the average graph be a straight line?
Not necessarily every time it will be straight line. That's why I said it is curve. I have not said it is a straight line. Best fitted curve.
So then how can we satisfy the linearity relation?
I'm coming to that point of linearity later. What I want to mean here, that best fitting curve or drawing of best fitting curve. When we are going to draw a best fitting curve, what we keep in our mind, that swing at both sides of the average curve should be such way that error should be optimized or 0 or reduced to 0. Okay, this is a first part you have drawn, or you have already drawn that kind of straight line or average line in your practical paper first year of 11-12. Now come to the point of linearity. What I said about the linearity? Linearity is the proportionality between what? Output and input. Linearity is proportional between output and input. Now I have drawn a input characteristic or input output characteristic of instrument. I found that the characteristics will have some kind of data. You have taken 10, 90 or 20 or 100, whatever. It might be like that kind of data. So when you are going to draw a straight line, characteristic of this one, what you can do? Can you draw a random line like that? He may draw that kind of dot covering that all point. He may draw a average curve. He may draw a nearly hyperabolic graph depending upon the distribution of the points. Depending on the distribution of data, it might be like that. Depending on the distribution graph, it might be like that. So many lines you can draw depending on the distribution of the data. Now, if you draw that kind of data, once you have drawn, that will be considered the static characteristic, or that will be considered the characteristic of the instrument. Now the point is what is linearity then? If you accept that line, then if you talk about the linearity, definitely there is no linearity. You will find it is exponential in nature, and exponential nature means it definitely will be like that kind of equations, or it will be like that. Sorry, it will be like that kind of expressions. So if you talk about the linearity, you will not find here linearity. But when you are going to accept that straight line with a minimum E, with a summation E, which tends to 0, applying limit theory of EI, or sorry, EI summation EI. Better, it is using limiting theory. Limit EI or I tends to 0, I tends to infinity. It's going to give you value of 0. That's mean the error is optimized here, and you are going to accept that line is a characteristic line of the input systems. Then we can say that this area will be linear. This line is linear, because we will find that change in ratio of input output, change in input and as well as output. Suppose here the ratio. What is the ratio? Delta y by delta x. Y is output, x is input. If you check out that ratio here, similarly delta y by delta x, you can check out the area here, delta y by delta x, and in all cases delta y by delta x is constant and same. Constant and same. And same. They are same. Then we can say this is a straight line like tan theta, like tan 45, like tan 45, or tan 40, or tan 55, whatever. It is fixed. So you can say this is a straight line where the output and output and input having a proportional relation. We have drawn that average line having a proportional relations between output and input. Okay, this is called linearity of the systems. But some systems produce such a data that you cannot draw this line. Some system will be there that you cannot draw this line throughout the whole span or measurement. Whole span of the measurement, you cannot draw this line. Line might be somewhere it will be linear, somewhere will be linear, but not in whole area. Like LVDT, I discussed last day, showing some picture of the LVDT. So LVDT have a certain characteristics like that. LVDT have a certain characteristic like that. So in that case, suppose we are moving that iron core towards the right side. Right side. Suppose we are moving the iron core towards the right side. If it is moving towards the right side and finally it is here. Finally it is here. Then we'll find that when it is moving right side, then the voltage at the particular this voltage across this one will be gradually increasing according to the particular instantaneous positions of the iron core. Is it clear? Is it clear? Can you remember the operation of LVDT? Sika?
হ্যাঁ স্যার
সিরিয়াল শেষ হয়েছে?
না স্যার তখন আমি
আচ্ছা ঠিক আছে।
হ্যাঁ
সো
স্যার আগের ক্লাসে আমি ছিলাম না তাই এটা জানি না।
এটা জানো না? তাহলে এটা দেখে বড় দেখি জানতে মানে বুঝতে পারছো কি? আমি যদি এটা প্রাইমারি কয়েল ধরি, এটা সেকেন্ডারি কয়েল ধরি, এটা সেকেন্ডারি কয়েল। এর মধ্যে আয়রন কোরকে আমি মুভ করাচ্ছি।
হ্যাঁ।
ইকো হচ্ছে তো এখন। ফোন মোবাইল মানে মোবাইল শুনতে পাচ্ছ?
হ্যাঁ স্যার শুনতে পাচ্ছি।
এই যে আয়রন কোরটা আমি এরকম জায়গায় রাখবো, লাইন অফ
স্যার শোনা যাচ্ছে না ঠিকঠাক করে।
তাহলে তুমি অফ দিতা
ঠিক শোনা যাচ্ছে না স্যার, অবভিয়াসলি ঠিক শোনা যাচ্ছে।
স্যার আওয়াজ শোনা যাচ্ছে না স্যার, ইকো হচ্ছে।
অনিন্দিতা?
ইয়েস স্যার, হ্যাঁ এখন শোনা যাচ্ছে।
Is it clear my voice?
হ্যাঁ এখন ক্লিয়ার স্যার।
So can you explain this one? If iron core is here, I mean the iron core is moving slowly towards that first coil. This is first coil, this is second coil, and this is primary one. This first coil and second coils are secondary coils. First coil and second coils are secondary coils. Now that iron core is moving towards the first coils. So slowly it's moving. So what happened? The voltage induced in the first coil is V1. So what about the V1? V1 gradually increase. Am I right?
Yes, sir.
So I am drawing that graph like that. For output will be here. Output across what? Output across the coil 1, gradually increasing. Now the iron core is here. If I move that iron core more, then iron core will be out of this one. So we'll find that linearity will be disturbed and
Decrease.
finally it will be like that. Now,
Yes,
if you're
sir.
going to draw the, if you're going to say or interpret about the characteristic curve, what do you expect to draw? Average line. If you are going to draw an average line here, are you doing justice toward the graph? Are you doing justice toward the curve or output? If you think of the average curve, then definitely this will be the best average curve. Am I right?
Yes, sir.
Or you
Sir,
will find
to variation.
if you think the variation sum of error, EI means this direction as well as this direction will be nearly zero or nearly zero. Then you expect that this should be the characteristic curves, linear curves. But if you consider this one is the perfect output curve of LVDT, definitely you are wrong. Because this region is not related with the output of output variations with respect to the input variation. Because definitely the coil is moved away from the coil 1 as well as coil 2. So the most of the line of force traveling through the air, not through the iron core. So that's why this disturbance happened. So what do we expect? The measurement area is here. What we expect? Measurement area is here, not here. So we don't need to bother about the average curve that time. What we have to draw? We have to consider the particular area where the system response is linear due to the change in input with respect to the.
Sir, can you explain once more?
Huh?
Can you explain once more?
You all please listen carefully.
Yes, sir.
If I am going to draw a LVDT, this is primary coil and two secondary coil here. Secondary coil here. This is coil 1, coil 2, and the voltage will be here V1 and V2. Output voltage of the system V0 will be V1 minus V2. If it is in these positions, it is energized current passing through the primary coil. There will be a line of force, and that line of force travel this way. And induce the coil 1 as well as coil 2, and both the voltage will be same, so output voltage remains 0. We have arranged this way that coil 1 will produce a voltage and coil 2 will produce a voltage, but equivalent voltage of the circuit will be V0 minus equal to V1 minus V2, means they will be subtracted. Now I place a iron bar, small iron bar. It's like an ice cream bar. Okay, I am pushing this one here. If it is here, what happened? It is behave like a magnet. So more line of force travels through the coil 1, then this one. Okay, so voltage here V2 might be greater than of V1. Now my question starts here when the iron core is here, gradually pushed, and iron core is here. I am drawing a output characteristics Position of iron core is input. Position of iron core is input, and I am drawing a characteristic curves. What will be input here? What will be input here?
The position of iron core.
That is displacement of iron bar. And what will be the output here? I consider V1. So we'll find that when iron core moves here and through here, there will be more maximum induction. There will be a maximum induction. There will be maximum induction. So we'll find the voltage will increase gradually high. And when iron bar is here, definitely the voltage due to the less line of force will be reduced. So the voltage might be having some kind of undershoot, overshoot this way. So if you talk about the linearity of the device, what you can do mathematically, what you can do, we expect that non-linear curve will be considered such way it should be linear. So that's why you try to draw a average curve this way. 1 minute, hold on. Yes, sir. Sir, class নিচ্ছিল স্যার বলুন স্যার বলুন স্যার না আমি কোনো আশ্বাস দেইনি আমি শুধু বলেছি যে এটা কি করে হবে আমি তো জানি না তুমি এখন ম্যাডামের হাতে ছেড়ে দাও ম্যাডাম যা করে করবে তবে আমার তোমার প্রতি সিম্প্যাথি আছে ও যে সব কারণগুলো দেখাচ্ছিল সেটা তো মানে দেওয়ার মতোই ও বলছিল ওর মেশিনে ল্যাপটপ ম্যাডল্যাব ইনস্টল হয় না আমি বাড়িতে বসে ম্যাডল্যাবে কি করে সার্কোগ্রাফ করবো তারপর উনি ডিসক্রিট ডোমেনে ইনভার্টেড পেন্ডুলাম বলেছেন আমি কন্টিনিউয়াস ডোমেনের পার্টটা করেই দিয়েছি তারপর উনি মানতে চাইছেন না উনি আমাকে প্রথমে কন্টিনিউয়াস দিয়েছেন আমি করে দিয়েছি তারপর ডিসক্রিট ডোমেনে বলেছেন আমি করতে পারছি আমি লাইব্রেরিও অ্যাক্সেস করতে পারছি না এই অবস্থা আমার পক্ষে এই জিনিসগুলো জেনে করবো কিভাবে তো আমি এই কথাগুলো জাস্টিফাইড এই সময় তো আমি লাইব্রেরি অ্যাক্সেস দিতে পারিনি কি করে করবো হ্যাঁ তাই ওকে আমি সিম্প্যাথি জানিয়েছি হ্যাঁ এটা তো সত্যি কথা একটু মনে হচ্ছে তবে তুমি ম্যাডামকেই পড়ে দেখো সব পয়েন্টগুলো রিকোয়েস্ট করে দেখো তো যদি হয় হবে নাহলে ম্যাডাম যা করার করবে আর তোমার পক্ষে আর কি বলা সব আমি এর বেশি কিছু এরকম বলিনি তারপরও ও যখন আবার নাচক মানতে হলো আমি দেখো উনি আমার দিদিমণি আমি ওনাকে কিছু বলতে পারবো না তুমি একবার আপনার কাছে অ্যাপ্রোচ করতে বলেছি উনি যদি একটা সলিউশন দেন আমাদের অনেক সমস্যায় উনি সলিউশন করাবেন তো তুমি আবার রিসার্চও বলে দেবে হ্যাঁ পুরো কি বলি বন্ধু সাথে ছেলেটার কথার মধ্যে জাস্ট বলে স্যার কোনো বন্ধুই তো কিছু করেনি আর এর কোনো তো সিলেবাসও নেই যে ম্যাডাম আমাকে পড়িয়েছে তারপর পরীক্ষা নিয়েছে আমি পারি ম্যাডাম আমাকে প্রথম থেকে অ্যাসাইনমেন্ট দিয়ে গেছে এবার আমার লেভেলে আমি বেস্ট আমার বাড়িতে বসে ইন্টারনেট করে গুগল করে আমি একটা বার করে দিয়েছি আপনাকে যদি বলেন তো আমি পাঠিয়ে দেবো না আমাকে পাঠাতে হবে হ্যাঁ এবার উনি বলছেন ডিসক্রিট ডোমেনে করতে আমি তো ডিসক্রিটাইজ করাটা ঠিক মতো শিখিনি আমি পারছি না তাহলে আমি কি করবো আমাকে আমার মতোই তো দিতে হবে না আমাকে লাইব্রেরি অ্যাক্সেসও দিতে হবে কিছু তো করতে পারছি না রেফারেন্সও পাচ্ছি না তাই আপনাকে বলেছিলাম যদি হেল্প করেন আপনার সবই তো বুঝলাম আমি কি করি তোমাকে বলি আমি ভেবেছি স্যার যদি না হয় ও রেজাল্টটা বেরোক তারপর একটা অ্যাপ্লিকেশন করুক এই সিচুয়েশন গুলো জানি তারপরে অ্যাসোসিয়েটি কিছু করতে নিশ্চয় ও সেটাই। শুধু তাই নয় আরো একটা ব্যাপার হচ্ছে সেটা নাকি স্কলারশিপ বন্ধ হয়ে যায়। ও কান্নাটি করছে এমটেক করে ছেড়ে দেবো, মাঝখানে তো আবার আমাকে বলছে স্যার আমি কি ঘুরে যাবো নাকি। না এতটা ডিপ্রেশনে যাওয়ার দরকার নেই, জিনিসটা সলিউশন হবে। আপনাকে কি বলেছে ওইটাই একই নাকি? না আপনাকে এটা বলেছে কি আমাকে ছেড়ে দিতে হবে, অন্য কোথাও চলে যেতে হবে, এমটেক বন্ধ করে দিতে হবে, এরকম কিছু বলেন? আমাকে বলছে যে আমি তাহলে কি স্যার এমটেক এবারে যদি হয়ে যায় আমি তো বন্ধ করে দিই তাহলে অন্য কোথাও অ্যাডমিশন নেবো, তাহলে তখন গভর্নমেন্ট টাকা দিচ্ছে, আবার কোথাও অ্যাডমিশন করলে আবার কি টাকা দেবে নাকি? আমি জানি না, আপনি আমাকে গাইড করুন, আমি খুঁজে পাচ্ছি না কি। সেটাই কি যে হবে আমি বুঝতে পারছি না, আমি তো নিজেই দিশাহারা হয়ে গেছিলাম। তারপর আমি বললাম ঠিক আছে তোমার প্রবলেমটা আমাকে দাও, আমি নয় করবো, কিন্তু আমি সময় করে উঠতে পারিনি, কিছু নিয়ে যাবো বসে একটা কিছু মেটেরিয়াল হোক। ও তো সেটা নিয়ে বলছে যে স্যার আমি ইন্টারভিউ দিতে যাবো কি আমার তো ভয় লাগছে, আমি এদিকে না সাবজেক্ট পেয়ে যাই পেয়ে যাই, হ্যাঁ এরকম বলছে। Sorry. So in that case, what we are discussing that there will be coils, so there will be certain kind of energized so coil one, and that's why we will find that kind of graph here. That kind of graph here. Now this is a threshold value. What I said, this is threshold value. After what? After what? I mean, after a certain value, the output start responding here. This is not actually threshold. This is called residual voltage. Residual voltage. A residual voltage. Okay. And after that, you will find the change with the change of the input coil or position of the coil. There will be a linear variation. Linear variation means proportional variation. And after that, when the core is out of the coil region, then there will be certain kind of non-linearity. So if you want to draw a average line, that is wrong decision. You have to check out the linear region of the response. You have to concentrate over the linear region of the systems. Linear region of the measuring systems. You cannot draw here the average line. You cannot draw here the average line. As I said here, because that average line will be here, which is not output of the, which is not actually for the input variation. Input variation. It is actually random output. Random output. So what is the actual output here? This is the actual output here, and you will find within this region it is linear. So if you talk about the linearity of the systems, definitely it is region based. It is region based, and in this region, we'll find the output, delta output by delta input is almost a constant. So that's why it is linear. If it is not constant, if suppose some instruments mean having that kind of response. You cannot say this is linear range. You cannot say this is linear range. You cannot say this is linear range. There will be certain kind of response which is not linear. Similarly, you cannot say this is linear range. In that case, what you have to draw? You may draw a carpeting line. Otherwise, you have to take a linearizer circuit. Linearizer circuit. Are you listening, boys, girls?
Yes, sir.
Yes, sir.
So this is what I want to mean, that if it is a non-linear in a particular region, still you have to use that instrument, because we have a lack of instruments. Sometimes the sensitivity or measurement of particular parameter is important, but we have a lack of some instrument to use here, measure the physical parameter linearly, which is varying linearly with the output. Sometimes we have a lack of such instrument. Then what we have to do? We have some instrument which may produce a non-linear output. What we have to do? Additionally, we have to add a linearizer circuit with this one to make this is linear. Example of this one, I am giving you an example. That is a semiconductor thermistor, temperature sensor. One example is semiconductor temperature sensor. It's mainly made of the principal ID equal to ISS e to the power Vt by what?
Vt by Q.
You can express it. Huh?
So Vt by Q.
কি আমার খেয়াল নেই, তোমরা বলো আইডি কারেন্ট
কেই স্যার কেই
কে
স্যার উপরে ভি ডিভাইডেড বাই ভিটি হবে, ই টু দি পাওয়ার ভি ওই ভোল্টেজটা ভিবিআই ডিভাইডেড বাই ভিটি,
ই টু দি পাওয়ার
e to the power VBI divided by VT.
VB
I divided by VT.
I
VBI মানে BI টা সাবস্ক্রিপ্টে থাকবে, হ্যাঁ, ডিভাইডেড বাই VT। ওটা ওই বিল্ট ইন আর ওটা থার্মাল ভোল্টেজ
-1
-1।
তাই তো? এটা ঠিক আছে? মনে নেই আমার, বলো। somebody confirm it.
স্যার এটাই স্যার।
VB by VT
স্যার আর আইডিয়াল না কনসিডার করলে একটা n মাল্টিপ্লাই হবে মানে ভিটির সাথে, নন
NVT
আইডিয়াল।
NVT, right? So in that case T is varying, right? T is varying with what? ID. So this is a semiconductor property. So if I am taking a semiconductor device, then we will find that the current through the semiconductor depend on what? Their forward bias voltage VB, which is constant, and NVT. VT means voltage across diode, and the temperature of the environment, right? So if we keep the voltage across semiconductor device same, if we keep the voltage across semiconductor is fixed, okay, then we are changing the temperature. We are changing the temperature, increasing the temperature. Then we will find there will be certain change in ID. Certain change in ID. As temperature is increasing, there will be certain change in ID. So there will be certain variation of ID. Now, what we used to do, that using that property, will usually made a semiconductor device which measures the temperature. Okay, that is a particular important device for temperature measurement. But the characteristic curve you will find is not linear. It's not linear. If you think that equations, then it is quite similar with ID proportional to ID by IS. Better ID by IS equal to exponential VBE by NVT, where VBE constant, where VBE is constant. So it's going to be EX VBE by NVT. So this is a ratio of current output which is going to be exponential in nature with respect to the temperature. Definitely we will not able to draw this line in the straight line. So what we can do, we can measure the output. We can measure the output drawing a straight line, average straight line, or considering a particular region where the curve is little bit straight. Then we can say that within that region that device can be used. Similarly, when we are going to do some kind of experiment and we found that our new experience having some response like that, and we are going to draw the straight line like that, that time we can express the linearity in terms of non-linearity. Okay, when we are going to calculate the non-linearity, what we have to measure? We have to measure individual deviation. So if there will be another parameter like that, we have to consider them all. We might have some kind of data like that. What we have to consider? The maximum deviation. Where has the maximum deviation happened? Like they have the maximum deviation happened here. So maximum deviation by by total error, total deviation. Okay, into percentage, I mean 100. This is called, let me check that it is a total deviation or something else. Just hold on, hold on. So look here, I have written something wrong there. That is the maximum deviation by the average value of the output. Average value of the output into 100. It's not actually the total value of the deviation. Then it can be infinite. If maximum deviation is 0, that can be 0. Also, that's why there will be some kind of problem. The maximum deviation might be here. Maximum deviations by average value. Average value means that average value we have drawn. Like a best fitted curve, this will be the basic value, average value. So if you consider this value, then this value will be our considerations, and this will be denominator, and that deviation will be maximum deviation. According to what we have to calculate, sum of this one and some maximum deviation should be the multiplied with 100 to calculate the nonlinearity. Okay, this is the graph where what I was explaining, that there will be some kind of actual graph which is nonlinear in nature. What we have to do, we have to draw a best fitted curve. An ideal transfer function curve, what? This is a 45-degree angle, tan theta is 45 degrees should be like that. So this is ideal transfer curve, but definitely it is not ideal. There will be certain intercept. But this is considered the best fitted straight line or the best straight line fit. Okay. Anyhow, using that base sheet plan tit, we can explain the nonlinearity of the system or linearity of the systems by terms of by calculation of nonlinearity, percentage of nonlinearity, and that's what the percentage of nonlinearity will give us an example where we have to calculate the percentage of nonlinearity of a certain characteristic curves in static analysis. Then it will be clear to us. Okay. Now come to the next point. The next point is drift. It's called drift. Drift means some instruments after running of several times there will be certain displacement happens in output or input. Output due to the change of input. I mean, in drift, in otherwise we can say that slow variations in the output signal of a instrument or measurement system, whatever you can say, a slow variation in the output signal of a measuring systems which is not due to any change in the input quantity. Get my point? It can happen after several uses of the instruments. It can happen after several uses of instrument. You will find there will be certain drift. Drift means what? The slow variations in the output signal of the measurement systems, which is not due to any change of the input signal. Any change of the input signal. Is it clear? What I said, drift. Drift can be defined this way. Drift can be defined this way. The slow variation in the output signal slow variation in the output signal, what I said, of a measurement system which is not due to any change in the input signal. Slow variation in the output signal of measurement system which is not due to the input signal. We will find that the ideal, suppose a measurement system is ideal measurement systems. Ideal measurement system means output should be like that, input should be like that, and their characteristic curve will be perfectly follow the tan 45-degree angles, and it will be the ideal response, and that system is called ideal systems. Am I right? So it might be the output might be the y, input might be the x. So y by y equal to x. This is the perfect or ideal instruments. Now after several use, we'll find that the we are starting at x is 0. Here x is 0 means y is 0. Am I right? If x is 0, then y is 0 in ideal case. Y is 0, x is 1, y is 1, x is 2, y is 2. Now if that system after several use, we will find that x by y will be like that. If x is 0, y is 0, x is 1, y is 0, x is 2, y is 1, x is 3, y is 3. So what will be that? X is 0 means it is 0, x is 1 means here, x is 2 means here, x is 3 means here, x is 4 means here, x is 5 means here. And what is output? X is 0 means it is 0, x is 1 means it is 0, x is 2 means y is here, means here, x is 3 means here, y is here, and then x is 4 means y is 4, x is 5 means y is 5, so x is 4 here. What I said, This is 1 2 0. Sorry, this will be here. 2 is here. 3 will be here. Okay, 4 will be here. 5 will be here. So look, that graph is like this one. So actually it was expected the graph should be like that. So we are expecting the graph should be like that. But after several use, we found the graph is like here. So there will be certain area, which happened due to what? Which happened due to what? Due to slow variation in output signal. Look, although I have drawn that graph here, but what I want to mean that the system's response is 0. I cannot connect this. I cannot connect this. Why I cannot connect this? The output is not here. The output start responding after 2. Let me draw that picture clearly. If ideal case, we consider this should be here and here and here and here and here. And practically what happened, the really after several use, the output input is here, output is here. I mean, y is here, x is here. When x is 0, sorry, x is 1, output is 0. X is 2, output is 0. X is 3, output is 2. And here 3, output is here. So that's mean 3, output is 2. It will be here. And x is 4, 4, output is 4. It will be here. If x is 5, output will be 5. Look, the output started from here. But it should be here, whereas after several use, the output started from here. And within that region there is no change in output, or very slow variation. So it is called drift. It is called drift. And basically it happened at 0, so it is called zero drift. It's happened at 0, so it is called zero drift. There will be same thing happens for zone. I mean at mid side, at the way at the middle region of the output. If we draw that kind of graph, we'll find that it is starting from here, but after that there will be certain drift, whereas it should be here. It happened here. That is called zonal drift. Zero drift, zonal drift. Another one is a span drift. Span drift. Span drift means it's happened in the whole regions. Means it might be like that. So whole span there is a certain drift. This is called span drift. This is X and Y. So what is drift now? Drift is a slow variation in the output signal of a measurement system which is not due to any change of the change in the input quantity. As I said, is a threshold. Okay, it's over. Threshold is defined as the minimum input or the smallest change in input that is necessary to produce the output. I mean, the output starts responding. Okay. And now another word is a dead band. Dead band. What is dead band? It is defined as the largest change in the input quantity to which the measurement system does not respond. What I said, it is the largest change in the input quantity for which output will never respond. What I said here? What I said here?
Is the largest change in the input quantity to which the measurement system does not respond.
So this is dead band. It means in some area in our characteristic curves, you will find no output coming out. Actually, it is called dead band. Within that span, within that frequency, the system cannot respond. Like band gap filter. Band gap filter. Have you studied this band gap filter? Band gap filter. It's like that. If you draw a frequency around this direction, amplitude direction, then you will find that 0 to any frequency. Suppose here is the 0 frequency signal, means there is a no frequency signal, and here is the maximum frequency signal. So within what, everything should be visible. Everything should be visible. Suppose a frequency generator. What is the frequency generator? I mean, at a sine wave generator. In sine wave generator, you just a sine wave generator is like that. A sine wave will coming out from the systems. That sine wave omega is varying. Omega is varying from 0 to, you may consider it's infinite. It is not actually infinite, maximum value. Then what do we expect in the graph? That every frequency signal should be present and will be visible. Now you allow that systems, allow all frequency signals to pass through a band gap filter. And band gap filter have a lower cutoff frequency and a upper cutoff frequency. And if the lower cutoff frequency is here, if the lower cutoff frequency is here, upper cutoff frequency is here, then when you allow that signal to pass through the band gap filter, you will find that within that region there is a no response. Within that range, we will find no response. And then after there will be response. So that means this is a domain where no output will be produced. Where no output will be produced. Or no output will come. But input is changing. It is a band gap filter. It is due to band gap filter. Similarly, some instrument having certain property that within certain change in input signal. I mean, not a certain change. It's a big change. Within that region, the output will not respond. Okay. This is called dead band. Similarly, there will be another parameters which is called span and range. Definitely span and range is very important to know about the instruments, because whenever we are going to use the instrument, we have to check out its scale. Like in multimeter, what happens when we are going to measure 1 kilo ohm, 1 kilo 1 kilo ohm on multimeter, then we have to put the pointer in a 0 to 1K measurement, right? When we are going to measure 1 ohm measure, then definitely we have to make the pointer in a 0 to 10 ohm or like ohm measurement. Similarly, mega ohm measurement, there will be certain point in the mega ohm measure in multimeter. So, can you remember them?
Yes, sir. So, আজকের জন্য ছেড়ে দেবেন?
হ্যাঁ,
নেট খুব ইস্যু হচ্ছে স্যার, নেটের ইস্যু হয় স্যার রাত্রিবেলায়।
স্যার 9:15 বেজে গেছে স্যার।
কালকে তো ক্লাস আছে না?
হ্যাঁ স্যার, কালকে সকালে ক্লাস আছে।
কালকে 12টা থেকে নেবো। হ্যাঁ, এই 12টা না 11টা থেকে নেবো। আমি জাস্ট
রোজদিনই সকালে ক্লাস হলে বেটার হয় স্যার, সন্ধ্যাবেলাটা একটু চাপ হয়ে যায় স্যার।
আমার নিজেরও সুবিধা হয়, কিন্তু আমি তো কি করবো বলতো, আমি অফিস করে এসেছি, তখন যে 5 মিনিট ব্রেক নিলাম, তার মধ্যে আমি একটু টিফিন করলাম, চা খেলাম, নাহলে সেই 10টার সময় খেয়ে বেরিয়েছি। হ্যাঁ, আমিও তো চাই আমারও তো কাজ হয়ে যায়। আমার অ্যাডিশনাল একটা প্রেসার আছে না, তাই সব অ্যাটেন্ড করতে সারাদিনে এতগুলো ফোন, এত ডাইমেনশনের কাজে আমি ক্লাসের জন্য মনোযোগ দিতে হয়। আচ্ছা, ঠিক আছে, আমি একটু জাস্ট বলে নিই। হিয়ার ইউ লুক, that is multimeter you have seen, na? This is a range selector. You have to select a particular range for the measurement. Suppose you are going to measure more than millimeter, I mean ampere current. What you want to do, you have to put your pointer here, because this range allow you to measurement for ampere range of current. But when you put the here and going to measure ampere range of current, you will find it is 1 and it will say over range, right? When you are going to measure microampere current, definitely you cannot put this pointer here. You have to select that range where micro ohm can be measured. But if you forget to put this one here, but your pointer is here, definitely you will find over range. I mean, there is no variation in that signal. It's over range. So that's why the range of an instrument when you are going to measure something is very important. So let me give me few minutes just to finish the static characteristic, or I'll start it from tomorrow.
Tomorrow, sir.
So tomorrow at 11:30 plus minus 30 minutes. Okay.
স্যার 12টা অবধি ক্লাস থাকে স্যার।
কার?
ওই যে ফ্লুইড মেকানিক্স।
আমাদের ক্লাসই তো থাকে স্যার
12টা থেকে।
হ্যাঁ স্যার, 12টা
থেকে না স্যার, 12টা অবধি স্যার।
তাহলে 12টা থেকে আমার ক্লাস তো
হ্যাঁ স্যার।
হ্যাঁ স্যার 12টার থেকে আপনার ক্লাস।
2 p.m.
হ্যাঁ স্যার।
হ্যাঁ স্যার 2 p.m.
Okay, then it's good. Joydeep must give me a call, huh?
Yes sir.
Okay, thank you. Let me take the
Thank
attendance.
you, sir.
Just hold on. Work your mouse video. So just let me read out the names. So Sudha Satto, Joydeep, Arijit, Obhirup, Arnav, Moinak, Moisin, Anindita, Ayusman, Aniket, Ornik, Gulshan, Saurabh, Parvez, Rajdeep, Jogesh, Soumik, Silpa, Anirban, Nishant, Mustafa, Subhajit,
Yes, sir.
Sangram, Surjo, Obhirup, Nilargo, Ankit, Sikha, Ashraf, Biplav, Sagar. Anybody left? Okay, thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.